Hello everyone, here is homework 12, intercepts. We define the intercepts of a graph to be the point or points where the graph crosses the axes. So, something you would expect, we call an x-intercept a point where the graph crosses the x-axis, and a y-intercept would be a point where the graph crosses the y-axis. So if we are given the graphs, like in these first two examples, all we have to do is identify the intercepts, and you could see that, let's say we go for the x-intercept first. These axes should be labeled x and y, right? Let me do this one ahead of time. And so if I want to go for the x-intercept, I can identify the point. Okay, it's intended to be right there on the x-axis. So just read that point, and the ordered pair would be in the x direction, -7, in the y direction, 0. So the x-intercept is going to be given by that ordered pair, -7 and 0. And just remember to, because it's a point, you have to write it as an ordered pair with the x-coordinate first and the y-coordinate second, separated by a comma and enclosed with parentheses. And so for the y-intercept, looks like this is the point, and just reading the point from the origin to get there, we're moving 0 in the x and 5 in the y. So therefore the y-intercept is going to be given by the ordered pair 0, 5. Okay, there could be, here's a situation where it's kind of, this is what we call piecewise function. Nothing to really worry about. You're just concerned about the intercepts at this stage. So if we go for the x-intercepts, looks like there's two of them. This point here and this point right here. So for this point, the ordered pair in the x, -3, y is 0. For this point in the x, 8, y is 0. So I want to list the x-intercepts off to the side. Again, make sure you put them in parentheses, written as an ordered pair. So -3, 0, and 8, 0. And then for the y-intercept, okay, it looks like it crosses right there. And that would be 0 in the x and a -3 in the y. So for the y-intercept, again, 0 in the x, -3 in the y. Okay, so notice that, and I mentioned this before as we were discussing other topics, for the x-intercept, y is 0, and for the y-intercept, x is 0. So notice in all these situations that's true. So we made a little note of that here, and that x-intercept occurs at a point where the y-coordinate is 0, and vice versa, the y-coordinate, or the y-intercept, occurs at a point where the x-coordinate is 0. So it's kind of like the opposites. So therefore, here's a little procedure. If we're given an equation and we want to find the intercepts, then if we're looking for the x-intercept, we would just simply let y equal 0 and then solve for x. And if we're looking for the y-intercept, we're going to let x equal 0 and solve for y. So here we're given an equation, and it says graph the linear equation by plotting the intercepts. One thing you could do, I'm going to do the side work down at the bottom here, but one thing that you can always do is set up a table of ordered pairs. Okay, because when we graph, we know setting up a table is convenient. And on one instance, we're going to choose x to be 0. So let me do that down here. So let x equal 0 And then we get into our equation here. X minus y is 5. We would get 0 minus y is 5. So we're just substituting the 0 in for x. And there's really no need to write that 0. We have minus y equals 5. And to solve for x, well, excuse me, to solve for y, there's really a 1 in front of there. You can think of dividing by 1 or even multiplying both sides by -1, that is. And we get y equals -5. So that's the ordered pair of 0 and -5 that represents the y-intercept, because they let x be 0. And so here's the axes labeled. 0 and -5 would be one of the points. And then to find the x-intercept, we'll let y equal 0. And then we get x minus 0 equals 5. Or x equals 5. So when y is 0, x is 5. So that's one thing we could do, is we could just put zeros, 1 0 in here for x and 1 0 in here for y, and then find the corresponding x and y values. So 5 and 0 is right there. And then remember, 2 points determine a line. The only reason we were choosing 3 points before was to double check. And if you want, you can. Find a third point. Oops, looks like I missed a little bit. Make these thicker then. But we'll get the idea. And I always label it the line with the equation after it's graphed. Okay, so a quick way to do this then would be just to simply make a table, put a 0 in for x, find out what y is, put a 0 in for y, and find out what x is. So I'll show the work at the bottom here. If we let x equal 0, then we get, okay, this is our equation now. So we get for plugging a 0 in for x, we get minus 0. And I think at this point I'm just not even going to bother writing that. We just get 3y equals 3, right? Because if we're putting a 0 in for x, that term goes away. So there's really no need to write it, okay? Just try to adjust the... Apologize for that. Okay, there we go. That's better. Okay, so solving for y, we just divide both sides by 3. So y is 1. So we have the point 0, 1. You know, and you could write an ordered pair next to this, but I think at this stage we'll just leave it as a table and hope that we all understand how to plot. And then for the x-intercept, we're going to let y equal 0. And then we get negative x equals 3. Because again, there's really no need to show the substitution of 0 in here, because the y term goes to 0. But then there's really a negative 1, so we do have to be a little bit careful here with the negatives. And to solve for x, we'll divide by negative 1. And so we get x equals a negative 3. So negative 3 and 0. So let me label the axes. There's the x, there's the y. And now our points. 0, 1. So 0 in the x, 1 in the y. That's right there. and negative 3, 0, so negative 3 in the x, 0 in the y. So our x-intercept, and then we can get a straight edge and sketch the line. Now, in my math lab, you have the line tool that we're familiar with, so you don't have to actually have graph paper and a straight edge. You can just use the line tool, but obviously you want to show the work and create the table. Okay, so a couple more examples, not to bore you, but just to be complete. Sometimes the equations, often the equations that are of this type, where you have the x, y on one side, and then constant on the other side, so our general form of ax plus by equaling c, those are typically the types that are convenient to use this intercept method to graph. We're going to see other methods of graphing, but here's another situation where that's the case. And again, what I'm going to do is I'm just going to create a table of x and y values, fill in a 0 for x, find out what y is, fill in a 0 for y, and find out what x is. And those will be the y and x intercepts respectively. So I'll show the work down here. If we let x equal 0, then we get, I mean, if you really want to show it, 2 times 0 minus 3y equals 6, kind of silly to show that, right? Because immediately minus 3y is 6, because obviously 2 times anything times 0 is going to be 0. So when we have this type of equation, you could just pretty much cover up the x term, and that's what's left over. And then we could see to solve for y, we need to divide by negative 3. So y is negative 2, so we'll fill that in. 0, negative 2 is the y-intercept, and for the x-intercept, we'll let y equal 0, and then we get, once again, is there really a need to show, I recopied 2x, is there really a need to show minus 3 times 0 equals 6, right? So obviously that term goes away. A lot of times you can almost even, if you get really proficient, you could solve these by inspection. Because if y is 0, I'm covering up the y here in the equation, and look what's left, 2x equals 6, so hopefully you're good enough solving that by mentally, and x is 3. That's the nice thing about some of these equations. Here's showing it literally though, 2x equals 6, and then divide. That's the nice thing about a lot of these equations that we're seeing, is the fact that they end up being pretty simple to solve. They're nothing really elaborate, because it's usually, 3-step process at the worst case scenario. Okay, so then the points, let me label the axes again to be formally complete. 0, negative 2, so 0 in the x, negative 2 in the y, so y-intercept, and 3, 0, 3 in the x, 0 in the y is our x-intercept, and those 2 points determine our line. So again, I always like to label it. Okay, now later on we're going to see a method for solving an equation that's in this form. This is kind of a special form. We mentioned this before, but this is where y is given explicitly in terms of x. That's what we call explicit form. And remember, one thing that we did in the last unit was, last homework that is, was we just picked a couple different x values and we found out what y was. And that's fine, that's a good method, but here they want us to use the intercept method. So again, I'm going to set up the table. This is how simple it is. because you only need 2 points. Just put a 0 in for, set up the table, put a 0 in for x, put a 0 in for y, and then do the work. So if we let x equal 0, we get y equals 3 times 0 plus 9. That was silly to show that. By inspection, y is 9 immediately. And then if we let y equal 0, then we get 0 equals 3x plus 9. There, the 0 you needed to show, because it is an equation, and there's nothing left on that side. So we have to put a 0 in. And now we need to solve for x, so this is a 2-step process. Bring the 9 to the left by subtracting 9 from both sides. And finally divide by 3. And so x is -3. So we'll fill that in. Once again, you could be writing the ordered pairs of numbers, but just filling in the table is sufficient. And so plotting the points down, let me first label my axes, x and y. 0 in the x, 9 in the y, so I'm way up here. And -3 in the x, 0 in the y, right there. And then once again, those 2 points determine the line. A little bit off, but I'm just going to cheat a little bit by making the line thicker, right? You should put arrowheads on both ends of the line. And then once again, if you want to label it, that's great. Okay, now here's a special situation. If the constant term, that is the number, is missing in this general form, then we have to choose a value other than 0 for x or y to find a second point. Notice how in all of the 4 equations that we just graphed, we had every part of this general form present. That is, there was an x, there was a y, and there was a number. So notice x, y, and number. This wasn't in that form, but you got it, x, y, and number. And if you look back at numbers 1 and 2, there was x's, y's, and numbers. Now the number's missing, the constant is missing. So if you set up a table of values, here, watch what happens. And you think you could do what we've been doing, that is where you choose a 0 for x and a 0 for y. If you let x equal 0, then we get 0 equals 3y, because here's our equation. And solving for y, we divide both sides by 3. So y is 0. So we get 0, 0. But notice, if we now let y equal 0, then we get that x equals 3 times 0, or 0. So 0, 0 again. So we have the same point, okay? The origin, actually. So we need another point. So therefore, you could pick any value of x or any value of y that you like. And here, it is advantageous. So this is something you need to pay attention to. It is actually a good thing to pick a y value and solve for x, because x is given explicitly in terms of y. And it doesn't just pick any value you want for y other than 0. Let's say 1. And so if I let y equal 1, then we get x equals 3 times 1, or 3. So there's our other point, 3, 1. And you could have chose any value you wanted for y. See, if you chose like x is 1, you're going to start getting fractions, like you'd have to divide by 3, so you get 1/3 for y. And that would be hard to plot. So because x was given explicitly in terms of y, that's why it was advantageous to choose a y value. Okay, so we've got the 0.31, that's right here. And there's the 2 points for our line. And just to show you all about different types of situations, here's y equals -4x. Notice that the constant is missing. So we might know right away what's going to happen. That is, if we choose a 0 for x and a 0 for y, we're going to get the same thing, the origin. So if we let x equal 0, then you could see that we have that y equals -4 times 0, or y is 0. But if you let y equal 0, then you get 0 equals -4x, and dividing both sides by -4, we get that x equals 0. So there we go again. The same point, the origin. And so we'll have to generate another ordered pair. And here, notice that y is given explicitly in terms of x. That is, y is a bunch of x stuff. So therefore, it would be advantageous to pick a value of x. And I'm just going to say 1. And then if I pick x to be 1, y is -4 times 1, or -4. And there's the other point that we need. So 0, 0, the origin. Oops, let me label them. The axes, that is, xy. And 1 and -4 looks like right there. 1 in the x, -4 in the y. And so there's our line. And again, I'm going to name it. Okay, so then the last page of notes in this section is revisiting a concept we studied earlier, and that is the special straight lines. If one of the variables is missing in this general form, that is, you either just have an x or you either just have a y, and you don't have both, then recall we have either a horizontal or a vertical line. So we did this earlier. Remember, you don't have to do this, but I'm just illustrating how you could realize what the equation of a horizontal line looks like. If you draw the axes and you draw a horizontal line is parallel to the x-axis. And here's an interesting point, the point where it intercepts the y-axis. And the coordinates would be 0 and whatever this distance is. I'm going to call it in general A units. And just think about it like the number 3, okay? The point is that no matter what value of x I choose on this number line, let me say this were 5. The coordinates of that point on the line, this horizontal line that I'm looking for, would be 5 in the x and A units in the y. Similarly, if I picked a point over here, let's say at -3 in the x, the coordinates at that point would be -3 in the x, but A in the y, because it's a units away from the x-axis. So notice that y is always the same. So the equation for this horizontal line is y equaling whatever that value of a is. And we could similarly argue the vertical line. If you draw a line, first draw the Cartesian system, draw a line that's vertical, oh, and I'm going to leave it at that. I should have actually chosen B for the value, but we'll choose A again here. This would be the point A0, and no matter which point you pick, above, below, it doesn't matter. Let's say this is where y is 4. Then to get to that point, I'd have to first move a in the x and then 4 in the y. And let's say this point were -2. Then I'd move a in the x and -2 in the y. So notice that x is always the same. And the equation for the vertical line is x equals a. Okay, so just look for the situation where one of the variables is missing and you know it's a special line. You don't have to memorize y equals is horizontal and x equals is vertical, because you could just use intuition. If y is equal to 3, then y is always 3. Put a point where it intercepts the axes, right? Because we know that's a point, 0, 3, where y is 3. And then ask yourself, what is another point that is, if I move up or down, I'm changing the y value. But this is telling me y is always 3. So if I'm going to pick a point, it has to be to the right or to the left. It doesn't matter where it is, but it would have to be along that horizontal line. So that's the graph of y equals 3. See, even if you created a table of ordered pairs, x and y, you pick x is 0, y is 3. You pick x is 1, y is 3. You pick x is 2, y is 3. No matter what value of x you pick, y is always 3. And so that's the horizontal line. So similarly here, x equals -4. All I need to know is that it's special. It's either vertical or it's horizontal. -4 is one of the points in the x direction, so right there. And then just ask yourself, can I move right or left? Well, if I move right or left, I'm changing the x value. And x is always -4. So the only thing I could do to get another point is either move up or down. You don't have to plot both of them, you just need one more. But that shows you that it's a vertical line. And even if you went to the table, right, it's telling us x is always -4. So there's -4s all the way down, no matter what. You can't pick any other x value because the equation is telling you x is -4. So y could be anything it wants. Okay? But x is always -4. So it's a vertical line. And so in number 3 and 4, they're disguised a little bit, but the same concept. Notice that x is missing here, and notice that y is missing here. So first obtain the standard form by solving for y in this case, by subtracting 5 from both sides. So y is negative 5. Okay, I'll label my axes. I'll go to where y is negative 5, that's right here. And then another point, I need one more point, and that point, y must be negative 5. So let's just say somewhere over here, but along, could be anywhere along that horizontal line. Create the table if you want. So same idea here, isolate the x first. Recognize that it's a special line because the y is missing, and we get x equals 7. And then your question is that horizontal or vertical? Well, if you memorized that x equaling is vertical, that's great. But if not, just go to where x is 7 on the intercept and pick another point where x is 7. And that's got to be along a vertical line, because if you went left or right, you'd be changing the x value. And there we go. Okay, so that's the end of homework 12. We'll come back when you're ready for homework 13.